Okay, so we've talked about solving systems of equations using graphing. And just to review, remember with graphing, that's our least preferred method because the reason why it's our least preferred is it's our least accurate method because we don't always have graph paper, and sometimes our solutions may not intersect at a perfect grid line where they're both integers for x and y. But the nice thing is about graphing is it gave us a visual to see what was going on, so we could see what we're looking for, where the lines intersect at, and it was easy to see when they were parallel, that meant that there was no solutions, or if they graphed to be the same line, that meant there was infinite solutions. So there were some advantages, but definitely some disadvantages to graphing. So then we talked about using substitution. Now, that had an advantage because it gave us our answer no matter what. You didn't have to estimate, you didn't have to do any graphing, which I know for a lot of people, they don't like graphing. So that was a nice thing about substitution, but the problem with substitution is if we ran into a problem or a system that looks like the one that we have here. Because in order to use substitution, we need to have one of the variables by itself. So if I had to use substitution to solve this system, I'd have to do a bunch of work ahead of time to get either the x or the y by itself for one of these equations, and then use that to substitute into the other equation, which could end up with some ugly equations, some fractions. So substitution isn't always the best method, so it's good to have a backup method, and that one is elimination. So the whole point in using elimination is our goal is just like what it sounds. We're going to eliminate one of the variables. Now, in order to eliminate a variable, they need to have the same number with opposite signs, meaning, let's look at the y's, for example, here. If I wanted to get rid of the y's here, I'd have to multiply the first equation by 2, because our goal is to multiply this first equation by a number where one of the variables, either the x or the y, would have the same number with opposite signs. And if you notice, the negative 6 and 12, if I take negative 6 times 2, I'll get negative 12. And negative 12 plus 12, they're opposite signs, so they would end up being 0. They would end up eliminating each other. But the idea here is we can't just multiply the y by the 2. I have to multiply everything here in this first equation by 2. So let's do that. So we would end up with negative 8x minus 12y equals 12. The other equation, we don't need to multiply that one times anything, so we're going to leave it as 3x plus 12y equals 3. And what we're going to do now is we're going to add these two equations together. So negative 8x plus 3x would be negative 5x. Negative 12y plus 12y is nothing. That's our whole point in doing this, is to eliminate the y's. So now when I add the other numbers, 12 plus 3, I get 15. Whoops. So to find out what x is, I divide both sides by negative 5. Doing so results in negative 3 as my answer. So I know what x is. I know that x is negative 3, but remember we're looking for an intersection. We're looking for a common solution. So there's going to be both an x and a y. So I'm going to put negative 3 into either equation for x and solve for y. So maybe you might think, well, maybe the second one would be an easier one to do that. So let's try that. So let's put negative 3 in there for x. It'll be 3 times negative 3 plus 12y equals 3. Again, what I'm doing is I'm putting it in here for x. And I could have put it in the other one for x, and I'd end up getting the same answer for y. But if I put it in here, I get negative 9 plus 12y equals 3. Add 9 to both sides. Well, that gives me 12y equals 12, so that means y would equal 1. And again, we could check our answers by putting negative 3 and 1 into both equations. I should get true statements. So when I put negative 3 in the first equation, I'd have negative 4 times negative 3, and put 1 in for y, so it'll be negative 6 times 1. I want to make sure that equals 6. Well, negative 4 times negative 3 is a positive 12. Negative 6 times 1 is negative 6, and 12 minus 6, sure enough, gives me 6. So that's a true statement. And if I put it in the second equation, 3 times negative 3 plus 12 times 1, that should equal 3. Well, 3 times negative 3 is negative 9, plus 12 times 1, or plus 12, sure enough, gives me 3. So that makes a true statement. So they both check, and that's what you should do when you're doing these problems on your own. You should be checking your answers just to make sure that you're doing it correctly, and that's how you'd go about it. Well, that's elimination. Let's try another one. So for this one, let's say if we want to get rid of the x's. Now if you notice, I have a negative 3 to negative 6. Anytime they have the same sign, it doesn't matter if they're both positive or both negative, we're we're going to have to multiply the equation by negative numbers. So now I would have opposite signs because negative 2 times negative 3 results in a positive 6x. But then I end up with a positive 18y equals a negative 18. So now when I rewrite the other equation, I have negative 6x minus 18y equals a positive 18. And you'll notice now that when I add these together, 6x minus 6x is 0, 18y minus 18y, that's also 0. And negative 18 plus 18, that's also 0, that's 0 as well. So I have 0 equals 0. So anytime, this is just like with substitution, anytime your variables cancel out and you're left with a true statement, that means you have infinite solutions. If your variables cancel out and you're left with a false statement, that would mean that there would be no solution. Let's look at the next one. Now the next one, if you notice, there's nothing I can multiply 7 by to get 10, and there's nothing I can multiply 5 by to get 6, to get rid of the y's. So I have to actually multiply both equations by a number here. So let's say if we want to get rid of the 6's, I'm sorry, let's say if we want to get rid of the y's. What we would do to get rid of the y's, it's a very easy process. You just look at what's next to the y in the other equation and multiply the first equation by that number. So I'll end up with negative 30 there is my negative 30y. So then to find out what to multiply the second equation by, you go and look at the first equation and multiply everything here by 5. So then we have a positive 30y. And if you notice, they're already opposite signs. So I can leave it as a positive 6 and a positive 5. So now I need to multiply everything in that first equation by 6. So I'll get 60x minus 30y equals negative 60. In the second equation, I'll have negative 35x plus 30y equals negative 90. Remember, we're adding here. We're going to add these together. So 60 plus a negative 35 is 25. So it'll be 25x. And negative 60 plus negative 90 is a negative 150. So now, when I go to solve this, I'm going to take and divide both sides by 25. And when I do that, I'm going to get x equals 6 as my answer. Again, all I found is x. Now I need to figure out what y equals. So when I do that, I'm going to put 6 into either equation. Doesn't matter which one I use. So let's say if I put it in the first equation this time, I would have 10 times 6 minus 5 times y equals negative 10. So this is going to be 60 minus 5y equals negative 10. Now I subtract 60 from both sides. Now make sure you bring this negative 5y, bring the negative down with the 5, so it's a negative 5y equals negative 70. And when you divide both sides by negative 5, I get y equals a positive 14. So x would equal 6, y would equal 14 in that second, or in this equation. So why don't you guys try one on your own here. Let's actually just do example 4. So for this one, why don't you guys solve this one on your own. So hit pause and hit play when you're ready to check your answers. Okay, so let's see what you did here. Now, if you wanted to get rid of the x's would be the easiest one to get rid of here. Because if you wanted to get rid of the y's, we'd have to multiply the first equation by a 5 and the second equation by a 2, but one of them would have to be negative. But with this one, if I just multiply the first equation by a 3, well, doing that would just give me 12x. Well, that's not going to help. I need to be opposite signs, so I'm going to use a negative 3. So I'm going to multiply everything here by negative 3. So it gives me negative 12x plus 6y equals a positive 6. Below here we have 12x minus 5y equals 3. Add those together, 6y plus 5y is just y. 6 plus 3 is 9, so I got y equals 9. So now it doesn't matter which equation I put in. I put y in for 9. I'm going to replace y with 9, so I'm going to put it in the second one. 12x minus 5 times 9 equals 3, or 12x minus 45 equals 3. Add 45 to both sides, and I get 12x equals 48. So that means x equals 4. If you divide both sides by 12, you get x equals 4. So that would be your answer for number 4 here. So hopefully you have an idea now how to use elimination, and good luck on your assignment.